Welcome to Target 42, finding polynomial equations given real and complex roots. In this particular target, the big idea is using this equation where you can write an equation based on y equals x squared minus the sum of the roots, x plus the product of the roots. So all we have to do is go through and find the sums and the products of each of these roots, and we can put those in the places in the equation, and we are good to go. So the sum of this is to add them together. The product is to multiply them, and it's really handy to use your calculator on this. We can just simply type them in. So you'll notice when I type these in on my calculator, I put a plus sign in between them once, I put a times in between, or just set them in parentheses, and that shows me the first answer is -6 for the sum, and the product is 10. It's a calculator typing activity. So then if it's that, then I just get -6 and 10, and then I can put that in my equation in each of those spots. So then my equation would be y equals x squared. Now be careful, because this is a -6 already, and we're putting it in a minus some position, so that would be like minus a -6 or plus 6x and then plus 10. And there is the equation that would give you the roots, -3i minus 3i. If you don't believe me, you can check that really simply by going to your program quadratic formula and typing in 1, 6, and 10 as your a, b, and c value, and you'll see that it says -3 plus I and -3 minus I, which are exactly what is up here. So we know that that works. Okay, the second one is about radicals, and again, it's just same stuff. Type it in your calculator. When you type it in your calculator and add them, you get 10. When you multiply them, you get 22. So it's a calculator typing activity. Then I get 10 and 22, so I do x squared minus the sum of x plus 22, and there's my equation. Now some people wonder, well, how do you do it with 3 parts like this? Well, if you have 3 roots, we know our answer is going to be an x cubed. So my first part of my answer is going to come from this one being x minus 4. A real root comes from this type of solution, this type of factor. Then this other part is -3 plus I, -3 minus I. All I'd have to do is add these and multiply these, and I can get it to be x squared, minus the sum of x plus the product. Well, the nice thing about this particular example is, again, all we do is add and multiply, and we can fill in this part of the equation. We just did that one up here. It's the exact same numbers. So therefore, it's x squared plus 6x plus 10. So I can just plug that in. If I didn't know that, though, if it was different numbers, I just add and multiply, not a big deal. Now I'm to this part, and then the next thing to do is to multiply those together. Because it has 3 roots, our answer has to be x cubed something. So then I'm going to multiply this by that. That's a perfect time to use a generic rectangle. So I'm going to use a generic rectangle and go x squared plus 6x plus 10 on the top, and then fill all of that in. In this first corner, obviously, that's x cubed minus 4x squared, 6x squared, minus 24x, 10x, and minus 40. Then adding those together, I would have x cubed plus 2x squared. So again, plus 2x squared, that's these two. Then this would be minus 14x, and this would be minus 40. So there is my whole equation right there, and that's the one that comes from those 3 roots. So again, the process with 3 answers is the first part is a real number factor, so we can just write x minus 4, and then do the sum and the product, get this, and then multiply those two by doing a generic rectangle and figuring those out. The regular ones are really pretty easy for this target, because all you got to do is add those 2 roots together and multiply those 2 roots together, and it's just remembering the formula that it's minus the sum of x plus the product.